Hello, Vivian. I'm sure they'll join soon. Hello, Boris.
Hello.
Hello, Marlo. How are you?
Good. How are you doing?
Doing well, doing well. Long time.
Yeah, it's been a while. Aha, the grown-up in the room, Alex. I always make him be the grown-up.
Oh man. No, that's not
I mean,
fair.
look at
Ah.
your background. It's so nice looking. It looks pleasant. Sunshine.
It's true. I'm at a hotel. That's I have to
I can
pay for
tell.
my
It looks
background.
perfect.
Yeah, yeah, yeah. Nice royal blue, navy blue thing. Makes me feel serious. Yeah,
See, you have the serious face, so you get the serious job.
yeah, yeah. Exactly. Nice to see you, Philip. Nice to see you, Vivian. Nice to see you, Boris,
Likewise.
Abby, Francisco. Nice to see you all.
Nice to see you as well. Same.
We got so many things to talk about today. Um, Francisco, have you joined this before? Oh, you're muted, by the way.
I join other meetings from FINOS, but is this from FINOS or from the CNFS?
It's kind of, I mean,
CNCF.
it's CNCF, but
CNC. Okay.
I'm a part
No,
of
so
both.
then I haven't joined before to this one.
Yeah,
But
cool.
yeah, I'm interested in OpenGRIS. And before work in JP Morgan's for many years, and we have our own kind of grid,
Nice.
all written in Smalltalk. It was
Okay.
so very weird.
Sounds fun. Are you at JP Morgan now? Is that where you're at?
No, I'm at home and no, currently unemployed.
Oh, well,
Mm.
lovely to have you. You can we'll volunteer you for all sorts of things if you're not careful. So yeah.
Yeah, man, my wife also volunteers me.
Oh, so you're used to
I
it.
know, yeah,
Hey, no
happy
problem.
to participate in things. So I'm learning a lot with AI. So luckily,
Awesome.
yeah, with those tools you can, yeah, it's like having a personal tutor. So
Yeah, for sure. Well, we'll give another minute or two to for people to join. It's good to know that my message to Finos crew picked up a few people because yeah, I all of a sudden realized like I'm a part of both. This is a Finos project. I should advertise it over there just as much as the CNCF stuff. So um,
What is FINOS? For
it's
those of
the
us in the dark.
financial open source foundation under the Linux Foundation.
I see.
It used to be separate, and then it got pulled into the Linux Foundation, run by Gabriel Colombo. If you've run into him,
I have not run
uh,
into him. Although
and
Colombo is a fantastic name.
yeah, yeah, and fantastic human. I like Gab. Um, um, yeah, it's an interesting group. They've had a lot of the sort of banks and I guess they call it sell side kind of crew on there, and it took us a very long time to join up with it because we were like, but we're kind of different. We don't care about some of the things the big banks care about, like all the regulations and all the security and in that way. We're just like yeah, Finos is funny because they'll get very excited about some the technology or AI thing, and then they'll be like, okay, but first we must determine the governance and the security and there's like months worth of making sure we're going to be careful enough to talk about it. I'm just like, but just do the thing already. And so, um,
yeah,
oh,
but it's a good initiative, especially from the bank. So when I was in JP Morgan before FINOS, any contribution to open source or whatever was like no impossible.
yeah,
And once FINOS is in place, so all the legal, so that we are in part of FINOS, okay, and then you have some root
Yeah.
So that's the nice thing of FINOS. But yeah, I agree that it's a bunch of many very different sort of projects from different banks as well. So
Yeah, and we've used a couple of the projects that in FINOS that I think Waltz was the first one, and Git Proxy is one that we're actually leading. Um, my team is doing a bunch of work on, it's exactly what it sounds. It's a proxy for Git communication so that people like us can use Git happier. Anyway, there's a bunch of useful projects, and OpenGRIS is one of them. We will be talking about it in a little bit. All right, and our ranks are filling up here. Nice to see you, Ritesh. Thank you for joining.
Hey, Alan.
Yeah.
Do you mind shooting us there's a passcode and we can't log into the Linux Foundation website from inside the bank.
Oh no.
So if
Um,
there's a passcode with the thing, my colleague is also stuck trying to get in.
huh.
If not, I can walk over and actually, let me see. I can ask him to join from his phone.
I mean, I can send the invite.
Also, Ritesh, you here just for
Oh,
30
passcode.
minutes,
Yeah,
right?
yeah. I see it. Yeah. One sec. Dum, dum, dum. Passcode is this. Um,
You respond to the email that you sent to us, if you will get it.
okay. Let me go to it.
so OpenGRIS is an initiative from Citibank or mainly developed by Citibank.
Yes, so I can give whenever we're ready, I can give a quick background as to how we got here. Alex, if you tell me the agenda and we can go to it.
Yeah, absolutely. There's a few things that we'll take care of first. Just some updates for the group overall, because we've got some good updates for just the running of this working group, and then we'll dive in and just use the rest of the meeting for OpenGRIS. So
Absolutely.
yeah,
Alex, can I interrupt you just for 1 second? I think Ritesh is here just for 30 minutes, so we might want to
oh,
reverse the sequence.
is that
If
true?
it's okay, if not, I can move the other thing. But
No.
if
Okay.
Let's do it backwards. It's fine.
okay, okay.
Yeah, we can be accommodating. Then let's dive in. Yes, Ritesh and Boris are both here to talk about OpenGRIS, which I think will be interesting to the scheduler crowd as a multi-cloud, multi-cluster dispatcher. Yeah, well, you take it away, Ritesh. How would you describe what you have wrought?
So the problem we're going to solve the first thing we're going to solve is today, and I'll get I'll go on the technical side, the motivation. Today, parallelizing applications into the cloud requires very specialized skill sets. And the problem we have with that is parallelization is orders of magnitude harder than vectorization. So for example, when we vectorize code to run on a pipelined architecture, we don't give two thoughts about it. It happens automatically. And parallelization to the cloud is far more involved. We have to, first of all, change the code, understand the how we are provisioning infrastructure, how many tasks we need, and that whole process is fairly hands-on. So the example would be we're still somewhat in the assembly world, and we really want to go to C or Python. So that is the motivation of OpenGRIS. Is we want to make parallelization implicit. Now there have been a lot of very good efforts in the past, like Dask and like Ray, but we want to take it to the one more step beyond. So the first thing OpenGRIS provides is a couple of high-level interfaces where you can take functions that are functions and not jobs. You can take functions in your code that can be scattered and gathered. You can apply map reduce to it in some way. And you can just decorate a function and then turn on your connection to your scheduler, your scaler, and it will happen automatically. The library will figure out how do I take this function, scatter it into tasks, how many workers do I bring up on what image, in what cloud, do all that for you, send your function over, compute it, bring it back, and drop it in place into the code. The same thing can be done for a program where you have a call structure. You can just decorate the functions. It will automatically figure out the DAG structure and figure out I can parallelize this pathway, and this pathway can go in parallel because they don't depend on each other, and do all that automatically. And again, bring up the workers on your preferred image in your cloud environments, plural, and do that for you. So it sits at the other end of the parallelization stack. On one side, you have orchestrators, for which there has been a phenomenal amount of work in the last decade, and it presumes the existence of orchestrators. So it does not actually have built-in orchestrators. So today it can talk to EC2 Batch from Boris. Boris made a contribution. You can talk to EC2 through Orb, another AWS contribution. You can talk to IBM Symphony, and the Oracle Cloud contribution is on its way. And inside the bank, we work with Kubernetes. So it talks to the local Kubernetes control plane and plugs into that. And we can do that for Oracle. We can do that. We can do that for AWS. We can do that for IBM Symphony and soon OpenShift. So it can do multi-cloud. And then what can also come in the middle is it can do things like, well, I have captive capacity, also called on-prem, and I have cloud capacity, which might also be captive because you might have commitments for it. And I want to intelligently schedule across this. So I want to first use up my captive, then go to my Elastic, and then do this optimization. So there's a notion of policies in the engine, and which we're still working on actively, and it can do that. But inside, when we use it, we can actually do this waterfall, use the captive, then use Elastic, and so on and so forth. So that, in a nutshell, is OpenGRIS/Scalar. Scalar is the implementation. OpenGRIS is the standard, and the focus primarily is on the developer experience, the user of the API, how quickly they can take a workload and parallelize it. Our goal is hours and not hours to days and not months. And now on the OpenGRIS, the website that we rolled out during FINOS, we actually have some quick start examples where you can take some piece of code. Again, the big presumption is your code is functional and doesn't have a lot of deep state, right? So if you have this functional code, you can annotate it, you can parallelize it, and you can set up your cloud configuration in a matter of an hour or two, as long as you have vanilla AWS, and then off you go. So, Boris, anything to add? And I'll pause there.
I think this is very good, explanation from just the same thing, just said differently, the way I look at it, and that's the reason why once I met Ritesh and looked at what Ritesh and team created, I jumped into it immediately and contributed AWS Batch support, because it basically solves two problems that resonates very well with customers. Developer experience and the change impact when you move in between schedulers, which we know very fragmented market, and we solve that problem by supporting array compatibility API, which is much higher productivity API versus typical grid scheduling API. And second one is develop multi-cloud, multi-platform, I call it engine room orchestration, which I have basically quantitative lens into all of this. As a quant, you don't really care, right? As long as you get right price performance out of it, you don't care where it runs, right? And this is basically two problems that OpenGRIS is solving, and that's why I joined immediately after talking to Ritesh.
A couple of hands I see up. Francisco, you want to ask a question?
Yeah, so my question was when initially you mentioned that the function, so you decorate Python functions to distribute. So there are two questions. One is whether in that batch, or if you batch a lot of functions to be distributed, some of them can go to a cloud and some to the other. Yeah. And the other is what happens. So one of the difficulties is estimating how long will they take. because
Yeah.
one can take a lot longer than the rest,
Yeah.
and then you don't gain anything. So that more on that, I suppose you have like an infrastructure to estimate how long they will take.
Yeah. So I think it's a both good question. So the function, so one, again, and this is again an opinion we have, right? And there are many other opinions, and they're all equally valid, right? To me, the paradigm of when most things run in the cloud today, you have to construct a job, right? A task. And that's like this classic Slurm mechanism. And I find that it kind of breaks the thought process, because we're writing a program and I want to parallelize maybe a function or two. So to ask a end user, and by end user I mean here developer or quant, to say, hey, now take your workflow and totally rejigger it as tasks, it breaks their programming paradigm, right? It's a totally different way of thinking. So we wanted to come back to the function paradigm and say, I'm giving my idealized use case. Somebody is sitting in Jupyter Notebook, in somewhere, and they're computing something, and they say, this function I want to shoot after the cloud. They can just decorate that and then say, on which input, which parameter of that function do you want to split? And you can give it a simple split function. It might be a list, and you can say, just split the list, one by one. Or you might have a more complex partition function. Take these three parameters, a custom partition function. That'll give you the data chunks, and that's classic data parallelism, right? So you tell it how to chunk. You can give that directive. You can write that function, and then you can write the symmetric function, the combine function. And right there, when you run your program, it will right there figure out, oh, I'm going to make 50 chunks automatically. You can give it a hint, or 100 chunks, 1,000 chunks, and it will do that. Now, the other question about how long does it take, that's a very deep question, because if I can estimate how long a program will take, I'm basically kind of in a way solving the halting problem, right? So figuring out how long a program will take is always a heuristic at best. There's no guarantee, because the program might never halt. It might never stop running. But we can do simple things like, we can take the first element and compute it and see how long that takes, across the board, and estimate that. In the future, we have plans that the layer in the middle between the user and the orchestrators will learn from past workloads. So if Francisco give a workload and you can sign it somehow, you can hash it, and you can in the past this took this long, and then in the future I estimate this. But again, that's not a guarantee of the job ever finishing, because again, Turing's halting problem, right? We're back in the same place. So these are heuristics, and in the scheduler would need to be adaptive to that.
So that means that it's more like for prototypes, not for production ready. You don't want to use this like in a running your overnights or something like that.
Well, we have been using it for 2+ years internally for fairly significant workloads, and it works. Now, what I'm going to get to is there's no scheduler out there, or orchestrator for the matter, that can figure out how long a job will take with a guarantee, right? So that's it. That's my only point, right? So it does estimate something will take this long, but it doesn't like make a hard guarantee and sort of live by it, because we know theoretically that's not possible. It's against the laws of physics for computing.
Thank you.
And a few more things I want to add to what Ritesh said. From my experience, there is no real difference between function and a job, right? It's just a way to hide what I call archaeology of submitting a job and package it so it's implicit rather than explicit. So when you quant and focus on solving quantitative or quantitative problem, it definitely breaks your concentration and focus. When you develop, call it local, small scale functionalities that you want to test, that you want to test, and then you have to terminate, switch context, right? Switch context and start writing non-trivial amount of code just to be able to execute it in parallel. So here you just decorate the function and off you go. That's the difference.
I mean, I guess what I was hearing was that like you want to be able to sort of hand off the scheduling to other schedulers, right? Or that is a like use IBM Symphony, right? That
Yeah,
you're going
yeah,
to hand off to this other scheduler at some point. And so
correct,
can you sort of
correct.
describe the interplay between
Yeah, yeah,
like what is taking care of what? Like, are you scheduling
yeah, yeah,
things? Is
yeah,
it scheduling
yeah,
things? Like what? Yeah.
yeah, yeah. And Alex, again, another very, I would say, you put your finger on the core, one of the core issues. So there is our philosophy is we want to do minimal scheduling, right? As far as possible. Now, if I'm scheduling to something like a cloud provider, Oracle EC2, right? OCI EC2, then and let's say I'm not using AWS Batch, right? Which is like a Symphony in AWS as well. Boris, sorry, that's how I look at it, right? For my simple world, right? So in that case,
Whatever
I'm just
works,
using.
Steph.
Okay.
Whatever works.
Whatever works. Thank you. Thank you. So I'm glad AWS, PR reps are not on the line. So, or IBM, they would both object. So in the cases that are on-prem where there is no scheduler, Scalar will do the scheduling, right? It will do the scheduling. We want to hand off as much as possible. So in the case of Symphony, it is the Symphony scheduler is maintaining the underlying hardware, and we don't have visibility into it, nor do we want to get visibility into it. So we treat Symphony just as a single worker with a very fast, very high throughput. On the EC2 side, the system actually is starting up if using plain EC2, is actually doing the orchestration, is bringing up the images and the workers and actually assigning tasks to all the workers. So that is in some ways the most heavy duty part, right? Is doing the orchestration and the scheduling. In Symphony, it is doing almost none of either. So we will go anywhere on the spectrum. Our goal is to be able to plug into as many backends as possible. Some backends do a lot of orchestration. Some like Symphony do both. So we want to do de minimis work on the side. So it's a flexible approach. It's whatever the pool will do, but we are happy to hand it off to the pool, as much of the pool as possible.
Because to some degree, doing a simple dispatch. Oh, well, I see your hand, Abby. I'll have one more follow up, and then I'll switch over to you. Having a simple dispatch is actually useful for some of us. I mean, that's where Armada started. I think, Marlo, you were looking for something along these lines.
Yep.
What's interesting, though, is will you stay just a simple dispatch? Because the next set of questions that this group might start asking you about is like topology awareness, data locality, and then all of a
100%.
sudden your scheduler
100%.
starts to build more and more intelligence into its top layer, and it's no longer a simple dispatch. It's almost a very complicated scheduler all of a sudden. And I say this, don't worry,
Yeah.
like I say this as somebody who works on Armada, which started as a simple dispatch and now is a complicated, like makes very specific placements within Kubernetes. So it's just like a trend that I always see. Q is the
No,
same
no.
way.
I
Oh,
mean,
it'll be
Alex,
simple.
what you're pointing out is almost sort of the inevitability, right? Like what they were saying, every program eventually ends up sending email and printing, right? So which is so true, right? You're so true. And I think something similar can be said for these things like schedulers or they all end up eventually having data awareness, cost optimization, and we're already getting requests. We're getting requests like, okay, I cannot store compute cycles, unlike power, right?
Hmm.
I can store in the battery. I can't store compute cycles when they're not used. True, but instead of shifting supply, can I shift demand, right? So can I hold the job and realize, hey, this job takes 6 hours to complete, So I'll go back to what the question for Francisco. This job typically 6 hours to complete. I don't need it till 10 a.m. tomorrow. I'm submitting it now. Right now is 11:30 peak time. you can hold it. So you can hold the demand, hold it, and then submit it at 10 p.m. Already we have intelligent, pool scheduling where you use this pool first because it's a captive pool. We already pay for it. It's on-prem, right? So-called on-prem, even though nothing is on-prem anymore. But it's captive, it's prepaid, right? So I paid for it. So first use that, then use this, then use this. And some of the discussions we're having with people is, well, why would you not take all the workloads and the ones you know about that are fairly deterministic, and now you say some fraction is the workloads are predictable, and try to bin pack them into my captive cluster, right? You know the timings, you know this. So we were already getting into those discussions. So I do think, yes, there will be intelligence in that layer, but there's no value for us in managing, in orchestrating or scheduling onto Symphony. That software takes care of that. So the approach there here is where the backend is intelligent, defer to them as possible. Where it's not, you do the work. Yes, there will be intelligence. Yes, there'll be data awareness. For example, if my compute can run more cheaply on, let's say, OCI, but my data is sitting on AWS, clearly that will not work. The scheduler will need to become data aware.
Yeah, Abhishek, sorry.
Ritesh, I could not have said any better than this.
Thank you. AWS should be paying me, Boris.
So you already getting the check from IBM? We'll have to match that. All right.
The next
Sorry,
question is from IBM, so I would hold.
Abhi.
Yeah, I mean, so yeah, it's so thank you for sharing your use case. It's very interesting, right? So and also exciting as an ex IBM LSF developer. It's exciting to see Symfony being used. And anyways, so my question about the dispatch is, so dispatch for you is basically spawning the resources on the remote cluster and then submitting the job. Is that the definition of dispatch for you?
So again, coming from the user world, from the user point of view, and I'll put it very simplistically. When we run a compute, we just wanted to execute. So in this case, the scheduler brings up the appropriate image, by that we mean environment, where compute is available, runs the workers, dispatches, and then sends the functions to be executed, and then brings the results back, and then shuts down the workers and the image.
So the scheduler is basically the cloud provider or some other scheduler that you rely on to bring the resources and all. And until
Yeah.
then, that scheduler parts the job that you just dispatched. I see.
Correct.
Okay.
Correct. So for example, we plug into this release from AWS. It's called Orb, and Orb is a framework for plugging in different compute providers. And so you can actually write a adapter for Azure, an adapter for GCP using Orb. Orb is open source. I think it's a joint collaboration between AWS and Morgan Stanley. So it will manage a lot of the semantics provided by cloud providers.
Right. Okay. So one last question, right? Like sounds like this function dispatch and all. I mean, I know for obvious reason you may not use it, but there's an open source framework called Ray, which has heavily explored this function dispatching and other things. So have you ever considered using that?
Yeah. So today, Scalar provides a Ray compatible interface.
I see. Okay. Okay.
Now again, I want to go back to, we were using Dask. I was using Dask for a long time. And huge fan of Dask and other similar tools, and the Ray is part of their family. The challenge still is, I, as a developer, need to orchestrate the workers on the backends.
Mhm.
Now, in most use cases, you have one backend. So it's okay, so it's easy. But still, I got, okay, how many workers do I need? How many images should I bring up? So on and so forth. Which one should I use of this whole, 300 instances available in AWS? And they keep growing, right? So So this layer takes care of all that. You don't even know that some instances were bought up on EC2. Your image was run, how many workers were bought up, how many cores were used. It just does this for you, right?
Mhm, mhm.
The whole thing happens automatically. So you just decorate, you run, and the whole thing happens, and then you just get a bill in your account, right? So that is for us, from a developer perspective, the most frictionless. Clearly,
Right.
something handwritten, just like handwritten assembly, will outperform compiler generated assembly in 5% of the cases, right? But 80, 90% of the time, it is pretty darn efficient.
Thank you. Thank you.
Curious what other thoughts people have. I see, Jonathan, you have any application for this kind of thing where you are?
No, again, I think as was pointed out, like the Ray and Dask are sort of more relevant for us.
Interesting. Is Ritesh's sort of problem statement not relevant, do you think? Like the having to re-engineer or like create the tasks after you've done the functions? Is that not a problem?
I imagine there's something else that exists in this space that that it's not necessary to have this in the first place.
How so?
You know, I missed the first 15 minutes of this talk, so I'm
Oh,
I never
okay.
forgot
All
what
right.
we talked
Sorry
about.
to put you on the
I
spot.
So
just caught the last 5 minutes, and I just my impression was like this, as you pointed out, you're reinventing the wheel, and there's probably something that can do this just as well.
So just one comment on that. If you're using Ray, anything coded up in Ray core can run here, and the goal here is can here meaning through OpenGRIS, and OpenGRIS is designed to orchestrate your jobs across. And I use the word function and jobs interchangeably because they truly are. So you can run it across different regions in different clouds. You can run it across different clouds. You can run it in hybrid. In fact, Ritesh and I did keynote where we demonstrated a single job comprised of multiple tasks running, half of it running on-prem and half of it running on AWS. So that's value add in addition to what Ray can do. So in other words, if you anything coded up in Ray core, you can run on your Ray cluster. But when you get into hybrid economics-driven orchestration, this is where OpenGRIS seamlessly you can just reroute through OpenGRIS and take advantage of it.
Jonathan, I really welcome if you have any other examples of this problem being solved. We solved it just because we couldn't find anything else that could do this. But if something else exists or has solved similar space, I really would welcome knowing about it.
Who is your end customer? Who's the end user base that is
The end
necessitating?
user, yeah, the end user base is quants, quantitative modelers, analysts, and engineers who are taking workloads and running them in the cloud. So they are the actual target audience.
Okay.
So an analog would be a scientist who's doing some simulation, let's just say Monte Carlo, and a multi-step Monte Carlo, and they want to parallelize it. Sitting in their MacBook Pro, they can do this. They never had to touch EC2 apart from configuring it for the first time, and then off they go.
Okay.
Yeah, I mean, I've seen, certainly like Yellow Dog shows up here often enough. There's plenty of people who
Right.
are trying to like orchestrate multiple clouds and trying to burst into different places. Um, certainly somebody's worried about that part of it. Francisco, you.
Yeah, so my question is about the functions that or tasks that are being parallelized. Um, so from your description, it looks like you can parallelize any function, but I
No,
guess you
no,
need to
yeah,
take care
it's
of
limited.
that
Yeah,
the functions have all the parameters and they don't have to read from files or environment and that sort of stuff, no? So from the designer, you have to
yes,
upfront thinking this will be parallelly
yeah,
stable.
yeah, yes, yes. So I think again, very valid point. It has to be a pure function, but it does support. You could send it to a cloud provider, and it as a pre-step you can attach local storage to it or S3 mount things, and that those functions you dispatch can open and read, right? And that's getting more into the actor framework now. Okay, read this and do this and do that. So yes, it does support that, but either it's pure or it reads locally. But if the state is not in the closure, you can't ship it over, then it will not work.
Yeah, I'm asking because, well, in JP Morgan, we have that problem. And then you distribute the task, but then the setup or the reading of the
Right,
file
right.
takes much longer than.
100%. And these are all very valid, very valid points about the efficiency of doing this. Yeah.
So
Okay.
maybe some other sort of I don't know, not basic, but often asked questions like, do you have a notion of prioritized fair use, fair share? Do you have things like preemption, like affinity, like anti-affinity kind of things, like any of those kinds of features?
Not in the tool presently, but on the roadmap. For our workloads, we just didn't have anything directly that needed that.
Yeah, and I suppose that goes back to my previous question about like do you hand off like the affinity, anti-affinity stuff to the scheduler you're handing off to, presumably those schedulers have those kinds of functions, but the prioritization stuff seems like it might be somewhere in the realm of what you were talking about before, where it's like you can, you're trying to judge demand, supply and
Yeah,
demand kind of
yeah,
stuff.
yeah.
So that could be with prioritization, but then these other
Correct.
schedulers also have prioritized fair
Exactly.
share stuff. So yeah, just trying to get a sense of
Yeah.
how those two would intersect.
So it's an interesting question, Ritesh, if you don't mind. I'm going to
Please,
jump
please,
in.
no, please.
Uh,
Yeah.
So a lot of these concepts become less valid when you start using cloud, because in the cloud you have access to theoretically infinite amount of resources. So there will be edge cases, but it definitely uh, entry barrier into grabbing resources and hence dealing with fair scheduling and preemption and things like that in a cloud are a lot less. Or in other words, an edge case where it becomes important is much further removed or down the road than on-prem, right? So that's why we kind of philosophy-free project where we delegate as much as we can. We delegate to Batch, we delegate to Symphony, but whatever we cannot delegate, we just implement.
It's interesting sort of objection. I don't know that that's always true. I mean, we heard Ritesh talking about like the sort of reserved instances, like you're gonna a bunch of these kinds of use cases when you're talking about huge spend, like you're gonna have negotiated an upfront cost to your compute, so you're almost back to the finite resource state that an on-prem situation would be.
Correct. That's I agree with you. This is actually a very good case in point where it does look like on-prem, but the ceiling is a lot higher. When you hit that, right? So it's definitely out there, and again, things like that's why we made a decision to delegate as much as we can, so we don't get into
Well, I think,
reinventing the wheel.
yeah, yeah. I think the point Alex is making, and again, is even if you do delegate it, you still have to do the meta scheduling, which you can't escape it, right? And if you have a captive pool and so on and so forth. So yes, Alex, very valid point. On the flip side, from the user perspective, so this for us a question of how much do you want to take on, how much do you want to tackle, and we were trying to take on the minimal amount of stuff possible. But on the flip side, what we see inside enterprises is there's a lot of capacity, compute capacity, locked up in different pools, and like immense capacity, six figures worth of cores that is not being used. And the challenge for users, end users is, I say quants and developers, is they have to go through a lot of development to access those pools. Just layers and layers and layers of complexity. And we want, by building this abstraction layer, they can onboard very fast, right? On the other end of the spectrum, in more nimble firms, buy-side firms, they are far more savvy about the use cases. There, doing this scheduling will be more useful. So there's a whole lot of different use cases. Some are simply about make it easy to access compute. That's where we started. What we see going towards is, make it more smarter and more cost optimal to use compute.
Francisco.
Yeah, my other question is regarding monitoring. Once you dispatch the tasks, some might take a lot longer than you expected, or some might be crashing. And how do you identify and then get the logs of what the crash is and that sort of stuff?
So we have Yin here, who's the chief engineer on this. Yin, do you wanna take that?
Hold on, sorry. Yeah. Hi, Francisco.
Yeah, so the question is about monitoring of the tasks. When you
Yes.
dispatch them, if you know how much they progress, or if the one that is crashing, how you recover the logs, or maybe
Yes,
there's a sec fault and that sort of stuff.
So when task is finished, we actually have the monitoring tool to monitoring the peak memory and also how long it takes, and it's a low it's pretty low definition definition of those. It's not like it's not recording every single second for all the usage you use. Like in 1 second, that task is how much percentage of the CPU uses. Maybe in the task it can be sleep for 5 seconds. So, but we in general we catch the lifespan of all the tasks, and also all the tasks the output is also being able to stream to the client side. And they also as you said, if the task is failing, all the log and the exception backtrace will be propagated to the client side too.
Okay. So if the task dies, then the client will be notified.
Yes, even the print to standard out or standard error, all the stuff, it will still we have the option to propagate to the client. But it will just like if the task create a lot of those prints, it will, of course, it will like give some burden to the IO. So
Thank you. I have another question, which is
sure.
the initial one. No, this is more like function and vectorization. So I think you, Ritesh, you distinguish where if you can vectorize or parallelize. So why that distinction, or what you mean by that distinction?
So yeah, I was giving a sort of motivation, right? Vectorization today is implicit, it's hidden, right? From an application user exam person. So let's say I write some C code, and as long as I don't do it extremely stupidly, the compiler will vectorize it. It will say, oh, this is an ARM CPU, this is a x86, and it will do it automatically. It will know how wide the instruction set is and do all
So
the
you're
array
talking
alignment.
about you're talking about CMD and that sort of stuff.
Yeah, but I'm
I
saying
think.
today that vectorization happens automatically, right?
Yeah.
Like
Okay.
we don't talk about it. We don't say, oh, my code needs to be vectorized. It just happens, right? But here we are, 15 people talking about cloud parallelization. So the cloud parallelization is extremely expensive and painful. And most engineers cannot actually do it. So what will it need? What kind of tooling will it need to make that process very, very implicit, meaning hidden, automatic, right? So that was the original motivation for ParGraph and PartFunder, the two libraries. Like we can enable a lot more people to do this seamlessly. And then what else is needed beyond that, right? So in the enterprise, that's a very big challenge. Now, maybe outside the enterprise and more, academia and everything, people are far more, ahead of the curve. But inside the enterprise, we have a lot of compute. What we don't have is people using it because
Yeah.
that skill set is a very big gap. So can we make it automatic? And when you're an enterprise, like what does an average quant know about,
Yeah.
Kubernetes and
So
cloud scale?
I work in JP Morgan. We build that sort of internal cloud in Smalltalk to do this sort of stuff for calculate risk overnight and intraday. So all the problems are familiar, as well as what you're saying, how to allocate certain so different business can buy different amount of compute, and then another problem is once you get the compute to a certain business, they will end up filling up even with things that they don't use. So that's a problem at
Correct.
another level, no? But
Correct.
once they have it, they will use it, and yeah, even if they are not taking advantage of the results and sort of stuff.
Just wanted to throw it out to the group again. Tommy, any thoughts, any sort of relevance for you in any of this?
Yeah, I'm here, Alex. I'm listening, but kind of multitasking at the minute, so
All right.
don't want to.
Just trying to spread the goodness around,
But thank you for asking, Alex.
Yeah. Vivian, any thoughts from you?
I don't think so. No.
Yeah. Well, maybe we'll start to wrap things up. I can start to talk about those updates that we missed at the beginning. Ritesh, if you want to stay on,
Yeah, great.
that'd be great. It's been
Thank you
lovely
very much.
having you.
Thank you we'll come back. Thank you for inviting us, and we welcome all feedback. It's open source. That's why we're all here. And on the FINOS, on the GitHub website is a documentation with quick start with examples. So please take a look. Thank you so much, Alex. Thank you.
Really, thank you very much for coming. We really appreciate it. Yeah.
Thank you.
So I wanted to mention the topics coming up. I think we want to get John Bellemaric back talking about the DRA stuff. We were just getting to, I think, the interesting stuff in that conversation, and then we ran out of time. So we're gonna get John back to talk about the latest updates in DRA, and then also getting Tim from Slurm, SkedMD, now NVIDIA, back to talk more. Again, we were just getting to the interesting bits in the topology awareness for Slurm, and so we will try and hit that up as well. Last thing was that Marlo has just recruited a whole bunch of people for the benchmarking stuff that James and Philip have been pushing forward on. So that actually might have a whole bunch of momentum over the next couple of weeks. Zhao, thank you. Oh, yep, nice. Thank you. We're losing people fast. We'll start again with these updates next time, because there's actually a whole bunch of good stuff that's happening. The benchmarking stuff, I've done a bunch of house cleaning this last couple of weeks that is, we've got all the notes and all the stuff and all the automation I've actually been sending out to different people to try and get more people into this conversation, and that's seeming to work. Well, let's stop there because we're down to 4 people. Thank you very much, Francisco, for coming. Lots of very good questions. Have you back anytime. We do this every 2 weeks. Jonathan, lovely to see you. Sorry for putting you on the spot earlier. And same to Tommy, Vivian. Appreciate it.
Right on. Thanks, guys.
Have a good one.
Thank you. Bye.
Thank you.
Bye.
See you.